Okay, this is a 60 Hertz model of the Incredible Edger, and I want to go ahead and measure the pulley ratio. This is the spindle. Got a piece of tape here so this little shim doesn't rotate. And this is the drive motor, which is a 60 Hertz motor. Okay, there's 1 revolution, 2 revolutions, 3 revolutions. There's 3 1/4. So it's about 3.3 something. 3 1/4 down here would be 3 1/2. So it's about here. This is an Incredible Edger that was bought in the USA. We try to measure the gear ratio here of the spindle versus the drive motor. So there's 1 revolution, 2 revolutions, 3 revolutions, 3 1/4, say 3.3. So this has gone 1 at the top, and I've already gone 3. There's 4, 5. So 5 is roughly gone 1.5. There's 6. There's 7. There's 8. There's 9. There's 10. So you roughly have 10 revs to 3. So there you go. There's the same ratio. 11, 12, 13, 13 to about, lost track. The other viewer had asked this question. I guess I didn't see the answer. They'd mentioned motor wheel diameter 71, spindle 21, 3.37 ratio. To measure this, I've never had the pulley off. I went ahead and tried to measure the outside of the belt and then the outside of the rim of the pulley, subtract the 2. I got all different numbers. That's why I was doing this test. Of course, this is in inches. I've got the inner portion of the belt where it rubs on the pulley to be about 66.5 millimeters. The small, I measured the outside of the belt, which is still hokey, minus the thickness of the belt twice. Got about 21 millimeters. So I got about 66 here to 20. It's really difficult to measure this because you got a spongy build. So I tried eyeballing this coming down here with the caliper to measure where estimate what that was, and I got too much variation. I got 23 on the little guy. I got a 23 millimeter. I got a 20.8, and on the outside, this one, the inner part where the belt rates, I got a 65 and a 60. So I don't know. Measuring this by turning is far more accurate. Unless I take the whole unit apart. It's kind of hard to get in here to measure this. So for clarity, we'll go back here, try this again. Okay, there we go. I can rotate this a little bit around. If you do what I'm doing here, and you don't have this tape, this is going to slip. So there's 1 on the motor. Whoops. Go back here. 1 on the spindle. 2 on the spindle. 3 on the spindle. There's 3 1/4. This would be 3 1/4. This would be 3 and at 45 degrees. This would be 3.375. This would be 3.5. So the number that you got was actually pretty close. So I believe, Sid, your ratio that you've got here is actually a good number for what, probably the same what I've got, because this would be 3 3/8, which would be, this is 3 1/4, 3 1/2, 3 3/8 would be here. So completely jives. Then I'm going to show another clip. I'll show the motor. This has basically got a standard 56 frame USA or North American motor. 1/3 of a horsepower. Excuse me, it's a 1700 RPM. I guess I said 36, so I screwed that up. 1700 RPM, and that's at load, the way they rate these motors. Okay, here's the motor. Valve door. Let's see if we can, I got a reflection off there. Now, what you can do, I mean, I want to do, this motor here, this is a 3-phase inverter drive motor, variable speed up to 6,000. You can run one of these off a converter that goes through and runs a 3-phase motor off a single phase. They're about 120 to 150 bucks. And you put in AC between 120 to 240 volts. And you can get 240 volts 3-phase out. And you can vary the speed. And I bought this particular one to put on a easy sharp machine, but you've got this part here that sticks down for the shaft, so you may or may not, you'd have to take and modify this thing completely and bore a hole in there, and then you get the height of the Z heights and stuff, so that's kind of a mess to do. And you can go ahead and get a control to vary the frequency. Those are generally several $1,000s. There's the unit again with the dresser off that I've spun to try to figure what the gear ratio is. Okay, for non-Incredible Edger owners, I've got a bunch of the stuff removed to do this. I've got the grind disc off, and I've got the balancing weight. I've got the dressing piece, got the knobs that go on top, and the pin that holds the dust shield gizmo on. And here's an American caliper in inches. I got one in metric. It's just whatever I got lying around. But anyways, over here, this is what I'm trying to measure in there, which is kind of hard to do. Then you go around here and you look at the nameplate. Nameplate looks like this. It's got a ball door motor. And I'll probably stick in a screenshot, which I'll insert. Okay, I'm going to try to figure out the pulley ratio here. I went through trying to measure the diameters. It got all different numbers, so I figured, well, let me just measure the pulley diameter, the gear ratio here. So there's 1 revolution of the spindle, 2 revolutions of the spindle, 3 revolutions of the spindle, 3 1/4. It goes to about here. So we got 3. This would be 3.5 here, 3.25, say 3.3. There's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. There you go, 27.